Welcome to Python data structure. We will discuss about linear search first. In searching, you can see, so there is an important search that is also called it as linear search. Here, what we are doing, we will take a list and list will be like this. And using list, I will search each and every element. Why we are taking the list? Because we have an indices subscript. So that's why. So list will be like this. And elements 15, 38, 56, 34, 76, 89, 94, like this it will be. And what exactly we are doing here is nothing but one minute. Okay. See, we have element 15, 38, 56, 34, 76, 89, 94. See, I wanted to search an element, my key element, okay, 34. So first I will start with the initial index. If it is, I am able to find, I will break here and I will come out and I will going to say that I found the element. Otherwise, I will going to search the next subscript, again next subscript, next subscript, next subscript, like that until I found. If I start from here 15, I will go to 15 is not my key element. Again, I will search 38. It is not my key element. Again, 56. It's not my key element. Again, 34. It's my key element, as well as I will going to find the position of that particular element. Position is nothing but index number. That is 3. So this is how we will going to do the linear search in Python. So we will going to implement this one using Python. Okay. So particularly I will going to use the ID that is called it as spider ID. Okay. Fine. We'll see that. So let me implement this one. So what we are doing is we are doing the linear search here. So first I will going to create a function. Using function I will do this. And after that I will going to create a list. Okay, first let me create a function here. My function is something like this, diff linear search. Okay. So what it will going to receive as a parameters arguments. So that is one is list. I will going to say li. Okay. Another one I will take what is that key element. Okay. Whatever the key wanted to search, that element I will take it. Now, so I will going to receive the list here. After that, I will going to receive the key here. So what we have to find here, we have to find the element which we require. So now what I will do, I will going to use the for loop so that I wanted to search the element one by one. So that's why for loop is better. For elements in, okay, list we have to check. So subscript wise, we have to check means we have to take the length of the list. So what we have to do for that, range function we have to use it. Inside that, use the length function again. So find the length of the list. Which length you want, it means I want length of the list which I receive as an argument here li. So that is all. Now actual logic is started now. If length if list, okay, in the list, if element, okay, so what we are receiving here, length means suppose length is some 5, okay, it will start from 0 to 5 means actually range syntax you know very clearly. Start, stop, step size, okay, starts from 0, that's why length of element, okay, list of element, nothing but element value. So that is compared, nothing but we will going to use the comparison operator here, you can see. And I will going to say, what is that? Whatever the key we are receiving, that key we will going to compare with that key. So this is what exactly we are doing here. Okay, this is actually real logic. So when I do this, it will go with the each and every index. Okay, so ELE variable will going to get the index number that will be compared with the key. Now, if I found it, okay, what I will do, I will go to return. Okay, I will return that is equal to index number. I will go to return. What is that? Element. return element. Variable you can take it. Okay. Otherwise, okay, otherwise what we have to do? So otherwise what I will do, I will going to say very clearly return -1. If you want it, you can able to mention 1, but I wanted index number, that's why I'm mentioning ELI. Otherwise, if you want it, see, if you are confusing, just you mention I. So here also, if you want it, you mention I. So just it's a way, I is a variable here. ELI is also variable. Okay, fine. So this is my logic. And now what I have to do, I have to send a list to this particular function. So that's why I have a list. Variable name is li, that is equal to take the list. So some list is there, takes any numbers. Let's take 55, 2, 99, 3, 45, again 7, again no, 28. So this is my list. Now, so this function I need to call here. So that's why what I will do, linear. So linear search. So linear search, what I'm passing the list as well as key. Okay, that's why I wanted to take the key. So I will going to give the key from my side, nothing but user input. I will take it. That's why key is equal to int. That must be int. Okay, input function I will use. Again, I will say enter the key. Enter the key. You want to find. Okay, so this is the key I will going to enter, and that will be passed to this linear search function. So from key, it will going to receive the value to this particular key, and everything is fine now. Now, so what I have to do, if I return I value, so it will come to this particular function. Okay, that one I will going to store it to some variable. So that's why I will want to say result that is equal to. Okay, now I will say if result not equal to I will say something like this. If result equal to, let's take if result equal to I, okay, if result equal to I will say that element found. Otherwise, if result, I will say if result is not equal to -1, let's take that's better. -1, if result is not equal to -1, I will say very clearly print, I will say element found, element found, element found, and you mentioned the result here. So because result is getting the index number, so that's why result. So this. So whatever the result is, see, if it is not equal to -1, if it is equal to -1, I will say not found. So that's why I written like that. So else say key not found. Right? Very simple. Key not found. Okay. So this is enough. The list. If you want to elaborate it, the list. Okay. So this is what you have to do. And if you want it, you can do it with the F stream also, F string also. So let me run this program. We'll check. Okay. So it is asking enter the key. I will going to say key value is 2. Now see element found at 1. Okay, we are putting element found at 1. And once again, I will going to run this program. I will say key number is 33 because it's not there. See the key not found in the list. We are getting this. Either you can do it in that way or anyway. So here what I mentioned here, result is not equal to -1. If result equal to 1, okay, then I will going to say element is found like that. So that's why we are returning -1 or 1 like that. So but I want index, that's why I'm returning 5 here. So this is the procedure you have to follow for the linear search. And if you want how this uh, flow is going on, I will show you that also. Hmm. Now see, so this is the list we are taking. Uh, I will change the color. Okay. So first you can see this. This is the list we are taking. Again, we are taking the input. That is what input we have given 33 and as well as 2 here. And what we are doing exactly here is nothing but I am passing this list. You can see this. I am passing this list to here. Again, I am passing the whatever the key I will going to give that one over here. These values will go to, okay, please observe here. These values will go to, okay. So the list value will go to here as a parameter. uh, from the arguments we are saying this is an actual argument, it is a formal argument. Okay, so this for this we are finding the length here. Okay, so length we will going to get it 1 2 3 4 5 6 7. 7 is the length, nothing but 0 to 7 months, and nothing but it will go on to end at 6. Okay, so nothing but range is 6. Okay, range, total range is from 0 to 6, it will go on to print. So it will take the indices. Okay, so I value L of 0 means, and I will going to find the key. If it will going to map with this particular key. So if it is equal, then I will going to say, so it will going to return the I value. I value is nothing but what? So that is 0 to, what is that? 6. Okay, but range is 7. This one we have to observe here. Range is 7. Range is 7 means 0 to 6 it will want to print. So it will going to return the I value, nothing but index value. If I am not able to find in the those in the indices, so it will going to return -1. So this is, so that's why I will going to confirm here. If the result is not equal to -1, I will going to say very clearly element found at that particular position. See here, at that particular position element found, I will going to say, otherwise I will going to say element is not found. So this is the thing we can able to observe. So I will erase it everything. Now this is the flow you have to understand about the linear search, and you can see the variables key what we are finding is 33. So here that's why we are using spider here. So key actually required is 33, and list you can see 55 to 99 3 45 7 28. Result is what we are getting is -1 we are returning here. That's what result. That's why this is very nice and helpful to people, so that what exactly result we are receiving, all those we can able to understand. So list I am passing this particular list, and these are the values. And result you can see -1. I will going to run one more time if you want it. See, I will going to provide the key something like 28, and please see this variable changes here. Okay, 28. Let's enter this. See, element found at 6. You can see. So what we are looking for? 28. So 0, 1, 2, 3, 4, 5, 6. At element found at 6. Okay. So if you want it to elaborate at position like that, if you wanted to do it, it's not required actually. Okay, so I will take one more. Okay, final one, last one. So I will take the value that is 45. That's it. So element found at position 4. So this is the result you will want to find. So key is looking for 45, 0, 1, 2, 3, 4. Okay, exactly we are getting 4. And result what we are getting 4 here. Nothing but index number, that is. Okay. So this is all about linear search. Thank you. Thank you very much.